Happy Monday, 7th graders. We're doing this. Algebra is back in session, so let's do it. I hope that you had a wonderful vacation. I worked in my yard and ripped out a whole bunch of bittersweet, and so hopefully we suppressed some of it and it won't come back. So let's do some algebra. Okay, we're going to do a review day today. We're going to review, I'm going to ask you to review foiling. So in the assignment that I'm giving you, there are some examples of me foiling. Remember, the firsts, plus outer, plus inner, plus last, okay? And usually when I do it, if it's kind of messy, if the numbers are big or yucky, then right above the parentheses, I write the outer, or the inner. I put one of them, and I put the inner or the outer below, and then I add those together for that middle term. So hopefully you know what I'm talking about, and if you don't, then contact me and I will do a full review of foiling, okay? But there are some special cases for foiling where we actually can recognize, and we've done this before, so this is a review. So I can recognize these two as conjugates, right? So 5x minus 2 times 5x plus 2, those are conjugates. I can say, oh, when I multiply conjugates, I get difference of two squares. So let me scooch over here. If I notice that these are conjugates here, then I know that they go down to a difference of two squares where I square the first term minus square the second term. Okay? So multiplying conjugates turns into difference of two squares. Let's see what I see here. I recognize here a, what is it again? Oh, a binomial squared. I see a binomial, single set of parentheses, squared. So this binomial squared is going to multiply out to a, that's right, perfect trinomial square. So perfect trinomial square tells me three terms. I'm going to multiply the first term. I'm going to multiply the two terms and double it. So 5x times negative 2 is negative 10x. And I'm going to double it, minus 20x in the middle. And then I'm going to square the second term. Whoops, it's not plus 2, it's plus 4. Okay, does that make sense? Great. All right, let's take a look at this one over here. So this was perfect trinomial square, comes from a binomial squared, quick and easy. Multiplying conjugates gives me a difference of two squares. Excellent. What if I am factoring? So now we need to go through this process of factoring completely. I've put in the attachments today, I've put in a factoring completely guide. You start with looking for a greatest common factor. In fact, of the problems I gave you, I don't think there's one that starts with the greatest common factor, but that's okay. You count the number of terms, and depending on the number of terms, you choose to factor. If you see two terms, you could factor in, and you could check to see if it's a difference of two squares. If you see three terms, you could check to see if it's a perfect trinomial square. And then that would be quick and easy factoring. If I have three terms and it's not a perfect trinomial square, then remember, if the first or last term is prime, you could put those in place and work out the other ones, right? And if they're not, and if it's complicated, then we use the AC method. And you can go back to the week before break and watch the AC method video if you need to, okay? I put a couple of examples, or I put at least one example in our work. Let's take a look at this one. This is four terms. I'm going to factor by grouping, right? I'm going to sort of split it up there. I've got x squared as my GCF, so I'm going to do GCF on the left, x minus 5. GCF on the right seems to be negative 1. I've got x minus 5. Remember, I'm looking for the same two binomials here. So let's see, I'm going to pull this out front, x minus 5, whoops, times x squared minus 1. Now here's the deal with factoring completely. We need to take a look at each factor and decide whether we can factor it further. Can it be factored? X minus 5? No, it cannot be factored. It's done. Okay, what about x squared minus 1? Does anybody recognize what this is? I see a difference of 2 squares. Perfect square, x squared, minus 1, a perfect square. So I'm going to keep my x minus 5. And then I'm going to take this x squared minus 1 and factor it into conjugates. Now this is done. And I can check and make sure. X minus 5 can't be factored. X minus 1 can't be factored. X plus 1 can't be factored. On the pages that I've given you, I've asked you to take a look at some of the problems. I said how many parentheses they're going to have at the end so that you don't stop too soon. The key is to keep looking at your factors until you are sure they can't be factored further, okay? So we're going to re-practice multiplying and factoring today with polynomials. We're going to get back to equations tomorrow. It's going to be awesome. Have a really wonderful day. Bye.